So we're going to look at some examples here of it. I mean, I did a few in the notes, okay? They're like, yes. You're good. It's just showing that two variables, like, literally vary directly with each other. That if you change one, it automatically changes the other one to be based on that. So it's kind of like your independent and dependent variables in science, in a sense. Yeah. So that's why, like, the extra stuff added to it, like at the end, or like added or subtracted, that's why we, like, that's not, because that's another factor playing into it. Whereas if I just change, like, X, then it would change Y automatically because of that. But then if I'm adding something to it, it's not changing it in the same fashion. So the first set of stuff, okay, the ones I did, like, as just some examples of, like, what is and is not direct variation and listing the constant of variation, that is, like, problems 18 through 23. Okay, they're not actually problems from that section, but that's what they're like, so we'll still do one or two of those. But anyways, so let's start with the first one. Say to write and graph direct variation, or a direct variation equation that has the given ordered pair as a solution. So starting with 4, we have -3 and 12. Okay, and that's all we're given. So we first want to find our constant of variation. Okay, we're going to do that by plugging in the values for x and y into that direct variation equation. We're going to see what our constant of variation is, and then basically just rewrite the equation. Okay, and then essentially we're just graphing it. I'm not sure if we're actually, we're going to graph a couple, but I'm not sure if I would actually have you graphing them on, like, your quiz or something. Okay, so we have the equation y is equal to ax. So I literally just plug in the values that are given. So y is 12. A, we don't know, that's what we're finding, and x is -3. So now to solve for A, I divide by -3. So I get -4 is equal to A. And then to rewrite it in the form that we want it in, we just rewrite y is equal to -4x. Okay, so that is the equation that goes through the given point, or that rather has that as a solution. Sorry, not through the point, but that is the solution of the equation. Okay, and then we graph it just like you would a regular line. Okay, so how would I graph this if I just gave that to you and said graph the line? Right here? Okay. And then what would I do with my slope? Okay, and you can just do the 2 points for these ones, and I definitely just missed that other dot, but oh well. Okay, but something like that. Okay, that's why I say we may only, like, I may give you a couple to graph in your homework, but we're not necessarily going to be graphing them, because if I have you graphing everything from 2.3, and I can see that you can graph a line, obviously if you can write the equation, you should be able to graph it. So, let's see, another one. Number 8, 24, -8. Alright, so what do I do first? Plug in the variable, so I get -8 is equal to a times 24. So what is a equal to? Okay, so a is -1/3. So then what is my equation of the line? Y equals -1/3 x. And then what is my graph going to look like? see if I can actually connect the dots this time. There we go. You feel okay about this? Just plugging in the numbers and stuff. So you plug in for x and y, solve for a, rewrite your equation. Sounds a little more complicated than it actually is. Yes. Nope. No calculator. Nope. You only get a calculator on stuff that we've specifically used it for in class. Or like a problem like the word problem on the last test where I let y'all use it for the one. Alright, so then the next set says the variables x and y vary directly. Write an equation that relates x and y, and then find y when x is equal to 12. Okay, so essentially we know already that they're going to vary directly, so we know we can just set up that equation. Basically the same thing that we just did in the last section, but we have instead now it says x is equal to -3, y is equal to -5. We know that they vary directly. So rather than this being written as an ordered pair like we had here, now they're just written separated, but the process is exactly the same. So we write it as -5 is equal to a times -3. So what is a? 5/3. Okay, -5 divided by -3 is 5/3. We get our equation written again. So what is our equation? Y equals 5/3 x. Okay, so that's the first thing that this problem is asking for. Okay, it wants two things. The next thing is it wants us to find y when x is equal to 12. So now we take it and we just plug in 12 for x. So when x is equal to 12. Okay, and in every problem it's going to be when x is equal to 12 for this section. It's just constant throughout the whole thing, so it's not going to tell you every time. So plugging that in, I get y is equal to 5/3 times 12. And what do I get then? What is y equal to? Yep. So the 3 and the 12 reduce down to give me 5 times 4, which is 20. So y is equal to 20. So that's the second thing we're looking for. So these problems should have two answers, or two things like boxed when you're done. Yes. The problem just says find y when x is equal to 12. Yep. So that's it. Yeah, and not just something I just picked out of the air. It is in the book. Let's see. Let's do another one of these. I'm going to have you guys try this one on your own. Okay, and then we'll go over it. 16. X is equal to 2/3 and y is equal to -10. Okay, and then we want to know what y is when x is equal to 12 still. So you're doing the same thing we just did in the last one. So set it up, find the equation, and then solve for y. All right, what is our equation that represents direct variation? Y equals negative 15x. Does everybody agree? Okay, that's correct. And what is y equal to when x is equal to 12? Everybody agree? Alright, so we start with plugging in the stuff to find our constant of variation, which is a. So I plug in negative 10 is equal to a times 2/3. Then to move that over to get a by itself, I multiply by the reciprocal. So I get negative 10 times 3 over 2. The 2 and the 10 reduce down to negative 5, and then times 3 to get negative 15, which is a, and then I just plug in that number for a in the equation, y is equal to ax. So y is equal to negative 15x. And then I come over, I want to know what y is when x is equal to 12. So I just plug in 12 for x into this equation here, and I get y is equal to negative 180. Any questions about these ones? Alright, just so you know, I'm not necessarily, well, we can do one more if you guys want, but 24 through 29 are the exact same type as this. The only thing is x is equal to negative 4. Okay. Just kidding. Thank you. Y is equal to negative 4, so it's a little different. We can do one of those if y'all want. We'll do, here, let's go ahead and jump to that, and then we'll come back and do the little section in between, just so we can see it. 26. X is equal to negative 18. Y is equal to negative 2. Alright, so how would I find A? Okay, so A is 1 over 9, so what is my equation? Okay, so y equals 1/9 x. So that's the first part, and then these ones, since y'all can clearly read better than I can, we're finding when y is equal to negative 4, we want to know what x is equal to. So what would I do here? Yep, so I set it up, and now I need to solve for x. So negative 4 is equal to 1/9 x. And then, as y'all said, multiply by 9. Okay, multiplying by the reciprocal here. So negative 4 times 9 is negative 36 is equal to x. If it's a fraction, yes. Because technically speaking, you're dividing, but if you divide by a fraction, you multiply by the reciprocal. So I just always, you will pretty much always hear me say multiply by the reciprocal rather than divide by the fraction. Yep, keep, change, flip. Do we need to see another one? I don't mind doing another one if we need to. Everybody's good? Okay. Alright, so then backing up to 18 through 23. Okay, tell whether the equation represents direct variation. If so, give the constant of variation. 23y minus 7 is equal to 10x. So, how would I tell if this is direct variation or not? Move what over? So 3y is equal to 10x plus 7, and then what? We're not done. We're not done. Solve for y. Y is equal to 10 over 3x plus 7 over 3. Okay, you have to finish it out. You have to get y by itself on the left, and then you can tell me, is it direct variation or not? No, why not? Yep, it doesn't have the form y equals ax. It has something being added to it at the end, so it's not direct variation. Alright, 22, 5y is equal to negative 4x. What do I do with this one? Divide by 5. y is equal to negative 4 over 5x is this direct variation. Okay, so it is direct variation. Okay, and don't forget you can write dv for direct variation if you don't want to write it out every time. Okay, and if it's not direct variation, you can write not dv just to make your life easier. What is my constant of variation? Okay, and if you want, you can shorten that to COV, constant of variation, if you don't want to write out the word every time. Make it a little easier. Any questions about telling if it's direct variation or not? Alright, so one more thing really quick here, and then we'll be done, and I'll give you guys time to work, is there are some tables on page 110, and they say to tell whether the data in the table shows direct variation. If it does, write an equation relating x and y. So this is kind of back to, if you remember, I think it was in 1.5 when we had the word problems with the tables. It's kind of like that. So let's look at some really quick and see if we can determine if it is direct variation or not. And you don't have to copy the table for these ones in your homework. I'm just going to do it so that y'all can see it really quick while we're going over them. Yes, kind of. Hold on, let me do both and we're going to compare them and see if y'all can figure out which one is direct variation, and then we'll talk about them. Alright, so there's your two tables. Can y'all tell just by looking at it which one's direct variation? Take a guess. What? 34? Alright, who says 34 is direct variation? This is purely a guess right now. We haven't talked about it yet, so I'm just seeing who thinks it. 34, who says 32? Okay, so it is 34, okay, and here's why. Okay, we're looking at whatever x is, okay, if y varies directly, they're going to be the same number, most likely with a different sign, or some multiple of the number. Okay, so in this case, we know that if it is, then y is equal to ax. Okay, so with the numbers, if I had 8 here and negative 8 here, then I solve for a, what would a be? Negative 1. If I did that with negative 4 and 4, what is a? Negative 1. Okay, if you get a constant value the whole time, then it's direct variation. Okay, because it's that constant of variation is what you're looking at. So you can check it that way if you want to, meaning then that when I go to write my equation, y is equal to negative x because a is negative 1. Okay, so you could check that with one or two of them. But if we did the same thing with 32, if I did it with 1 and 7, what would my a be? Yeah. So if I did that, a would be equal to 7. How about if I did it with 9 and 2? Okay, a would be 4.5. Okay, as soon as I see there's a difference, I know that it's not, and then I can just put not direct variation. Okay, does that make sense? Pretty easy, right? Just looking at it. Okay. All right. Any questions before I give you your problems? Awesome. So your problems are three, 11, 13, 19, 21, 25, and then 33. Okay, and just know really quick too, another thing with the tables, okay, it's not necessarily going to be equal to -1. You might get a fraction. Okay, so like if I had given you 31, you'd have something that's like -1/3, and then you'd have -2/6. Okay, but that reduces down to -1/3, so just know that that also is true, that you can then reduce it to make it the same thing, and that you should reduce it. But make sure, like, you show the steps like I asked you to. You don't have to write the y is equal to ax step every time, but you do have to show like how you're solving for a and stuff like that. And go ahead and graph number 3, because I only gave you one that involves graphing. But yeah, just number 3, the one that has that in the instructions. The rest of them don't say to graph anything.